Okay, so good evening all. So welcome back. So today we will be discussing the partial differentiation. In the partial differentiation, there is one concept left over, and that is one of the important concepts, that is the differentiation of homogeneous function. Partial differentiation of homogeneous functions. Now, what is a homogeneous function? So in the homogeneous function, suppose if you are able to express f of x can be expressed as x power n into g of y by x. So if you are able to express in this format, then we call this f of x is a homogeneous function. So if you take x power n out, remaining term should contain only y by x, and this kind of function we call as the homogeneous function, right? So for specific homogeneous functions, we have some formula associated with the partial differentiation. So that's what we are going to deal with. So if I give you an example of a homogeneous function, x cube plus y cube divided by 2x square y. So let us say this is f of x, or just 2xy like this. Then this can be written as x cube you can take out, and then y by x whole cube divided by, here if you take x square out, then whatever is left over is 2 times of y by x. Then this can be further divided into x into, or x power 1 into 1 plus y by x whole cube divided by 2 times of y by x. If you notice, so if you take x power 1 out, the remaining term should contain only y by x. See, it's only y by x. So x into g of y by x format. So this is what we call as the homogeneous function of order 1. So this is the order of the homogeneous function here. Got it? So here n is equal to 1. This is how you will identify a homogeneous function. Got it? Now, if the function is homogeneous, then the derivative, so just note down this, I'll erase it. Okay. So there is one theorem associated with the partial differentiation of a homogeneous function. If f of x is a homogeneous function, of order n, then x into dou f by dou x plus y into, let us say this is g of x. G of x is equal to x power n into f of x. Y into dou f by dou x is equal to n times of f. So this is the fundamental theorem associated with it. So here g of x is expressed as x power n into f of x. If that is the case, sorry, x power n into f of y by x, sorry, y by x. If that is the case, then x into dou f by dou x, y into dou f by dou y is equal to n into f. Now let us prove this. So here let u is equal to x power n into f of x, or g of x is equal to x power n into f of x. Then dou u by dou x. So what is the derivative of this with respect to x? So n into x power n minus 1 into f of x. Sorry, this is f of y by x. F of y by x. So n into x power n minus 1 into f of y by x plus x power n into derivative of f of y by x with respect to x. So this is f dash of y by x into derivative of y by x with respect to x. This will be minus y by x square. Then if you multiply, so if you multiply with x this entire thing, x dou u by dou x is equal to n into x power n into f of y by x plus, so x power n into f dash of y by x into, so this you can take as minus, and then this y and 1x will be left over into y by x. So this is equation number 1. So I have just done the derivative with respect to x and multiplied with x. That's it. And then do the derivative with respect to y. So dou u by dou y is equal to x power n is a constant because you are doing derivative with respect to y, and then f dash of y by x into derivative of this with respect to y will be 1 by x. Then multiply this entire thing with respect, so with y. So y into dou u by dou y is equal to x power n into f dash of y by x into y by x. This is equation number 2. Now if you add equation number 1 and 2, then this will be x dou u by dou x plus y dou u by dou y is equal to, so here this term and this term both will cancel out. So these two are one and the same but with opposite sign. So this will become 0, and what is left over is, this is n into x power n into f of y by x. So n into x power n into f of y by x. So but this is initially it was u. So this is nu. X dou u by dou x plus y dou u by dou y is equal to nu. So this is what we call as Euler's equation for homogeneous equation. Homogeneous equation. Partial derivative. Got it? So Ravindra, the question is, if g of x is a homogeneous function which can be expressed as x power n into f of y by x, then prove that x into dou f by dou x plus y into dou f by dou y is equal to n times of f of x. Got it? So n times of g of x, yeah, g of x. Got it? So this is n times of g of x. So this is otherwise x power n into f of y by x. Yeah. Any questions on this? Okay. So a little extension to this, that is, if you take the second order derivatives, so if u is equal to x power n into f of y by x, then x dou u by dou x plus y dou u by dou y is equal to n times of u. So this is the fundamental principle. Now if you take the derivative again for this function, so from this actually we can prove that x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus 2y plus y square dou square u by dou y square, and this is equal to n into n minus 1 into u. So this we need to prove. First you try on your own to prove that. So take the derivative of this with respect to x and with respect to y separately and then try to get that result. Yeah, this was done at BTech level, exactly. So in that case, I will skip that. So you can do it on your own. So there is nothing great in it. Note down one problem so that x dou u by dou x plus y dou u by dou y, x dou u by dou x plus y dou u by dou y equal to 2u log u, where log u equal to x cube plus y cube divided by 3x plus 4y. Can you show that if log u is given as x cube plus y cube divided by 3x plus 4y, then prove that x dou u by dou x plus y dou u by dou y is equal to 2u log u. Okay, so let me solve this. See this here, actually this function is a homogeneous function. Now I call this as z is equal to log u is equal to, so x cube, if you take it out in the numerator 1 plus y by x whole cube, and in the denominator x, if you take it out, 3 plus 4y by x. Now this is a homogeneous function of order 2. So of order 2. Then for this function z, what I can do is x dou z by dou x plus y dou z by dou y is equal to 2 times of z, but z is equal to log u, right? So here z is equal to log u. It implies dou z by dou x is equal to 1 by u dou u by dou x, and dou z by dou y is equal to 1 by u dou u by dou y. Now if you replace dou z by dou x and dou z by dou y, so x by u times of dou u by dou x plus y times of y by u times of dou u by dou y is equal to 2 times of log u. So z I replaced with log u. Then u will take to the other side. So x dou u by dou x plus y dou u by dou y equal to 2u times of log u. And this is what he asked us to prove. Got it? Understood? No, Surabhi? So what is the doubt you have? So here actually log u is given as this way. Now the principle x dou u by dou x, y dou u by dou y can be applied only for the homogeneous function. But here log u is a homogeneous function, but u is not a homogeneous function. Got it? So what we can do is, I take log u as z, where z is a homogeneous function, because this can be simplified in this format. Understood? Is this understood, Surabhi? Right? So once you understand this, now actually I can apply on z the principle of homogeneous equation, that is x dou z by dou x plus y dou z by dou y is equal to 2z, because here n is 2. Got it? So if you apply that here, yeah, so if I apply that x dou z by dou x plus y dou z by dou y is equal to 2z, but what I want is in terms of u, but here what I got is in terms of z. The relation between z and u is z is equal to log u. Now from this, dou z by dou x is equal to 1 by u dou u by dou x, and dou z by dou y is equal to 1 by u dou u by dou y. Now these values I will replace in this place. Now you will arrive at this. Got it? Note down one more. So the homogeneous principle can be applied even for more number of variables. That is, if there are 3 or 4 variables also, you can apply homogeneous principle, but it is always referred with respect to x. That is, suppose, so u can be treated as x power n into f of y by x comma z by x. So here denominator is always x with each variable, and x power n is taken out. For this kind of function, the homogeneous principle x dou u by dou x plus y dou u by dou y plus z dou u by dou z, right? So this is again nu. So this principle applies. Even if you have one more variable, let us say w by x, then this can be w into dou u by dou w is again equal to nu. So this can be extended to any number of variables. So this is the beauty of this. Now note down one problem based on this. If u is equal to sine inverse of x plus 2y plus 3z divided by x power 8 plus y power 8 plus z power 8. Then find the value of x dou u by dou x plus y dou u by dou y plus z dou u by dou z. Find the value of this. Okay, good. So this is straightforward. So exactly in the similar manner what we have done in the previous case. So straight away sine inverse of x plus 2y plus 3z divided by x power 8 plus y power 8 plus z power 8 is not in the Euler's homogeneous equation format. So for that what you can do is sine inverse, you can bring it to the other side. Then you call z is equal to sine u is equal to x plus 2y plus 3z divided by x power 8 plus y power 8 plus z power 8. Now this is an Euler's homogeneous equation. You can take x from the top and x power 8 from the bottom. 1 plus 2y by x plus 3z by x divided by 1 plus y by x whole power 8 plus z by x whole power 8. Now this is a Euler's homogeneous equation where n equal to minus 7. Now here on z you can apply x dou z by dou x plus y dou z by dou y plus z dou z by dou z. Sorry, this is u. I call this as p. This is p, yeah. So x dou p by dou x plus y dou p by dou y, z dou p by dou z is equal to n is minus 7 times of p, but p is equal to sine u. So here dou p by dou x is equal to derivative of sine u with respect to x So that is derivative of sine is cos u dou u by dou x. Similarly, everything can be done with respect to y, with respect to z. Dou p by dou y, derivative of sine is cos u dou u by dou y. Dou p by dou z is equal to cos u dou u by dou z. So here x into cos u into dou u by dou x plus y into cos u into dou u by dou y plus z into cos u into dou u by dou z is equal to minus 7 sin u. So if you bring the cos to other side, x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to minus 7 tan u. Got it? Is this understood, everybody? Got it? Okay. Any questions? Okay. Note down one more. U is equal to sin inverse of x plus y by root x plus root y. Root x plus root y. Prove that x dou u by dou x plus y dou u by dou y is equal to half tan u. That is exactly the similar problem what we have solved now. Half tan u. Then this is extended and x square dou square u by dou x square plus 2xy dou u by dou square u by dou x dou y plus y square dou square u by dou y square is equal to sin u cos 2u by 4 cos cube u. Can you prove this? At least first one you should have got. Yeah. What about the second one? Okay. So it is straightforward only. So we have solved this already. We will take from this. So x dou u by dou x plus y dou u by dou y is equal to half tan y, tan u. Now here, if you take the derivative with respect to x, then this will be x into dou square u by dou x square plus dou u by dou x. Apply uv on this. So x and dou u by dou x plus y into dou square u by dou x dou y is equal to half derivative of tan u with respect to x. So this is secant square u into dou u by dou x. So here there is one dou u by dou x here and there is one dou u by dou x here. Then x dou square u by dou x square plus y into dou square u by dou x dou y is equal to, so secant square by 2, secant square u by 2 minus 1 into dou u by dou x. Now if you multiply with x on either sides, this is x square, this is xy and this is x dou u by dou x. Similarly, if you do the derivative of this one with respect to y, So this with respect to y, then this will be y square dou square u by dou y square plus xy dou square u by dou y dou x is equal to, again it will be secant square u by 2 minus 1 times of y dou u by dou y. Right? So this is with respect to x and this is with respect to y. Now if you add these two together, that will be the LHS. So add 1 comma 1 plus 2. This is the LHS. And the right hand side will be, so secant square u by 2 minus 1, if you take it out, what is left over is x dou u by dou x plus y dou u by dou y. And this is again, we know that this is half tan u. So from that, so RHS will be secant square u by 2 minus 1 times of half tan u. So the simplified form is the answer. So this is RHS is equal to, if you multiply this, so 1 by 4 times of secant square into tan u, that is sin u divided by cos cube u minus half sin u by cos u. If you take sin u out, 1 by 2 also is out, and then 1 by 2 cos square u minus 1 by cos u. So this is sin u cos 2u divided by 4 cos u. So this will be the final answer. You are going to get it. Got it? This is cos q. Ravindra, what is the question? No, it's not negative. That is positive only. Yes, sorry, it's negative only. Exactly. Yeah, you are correct. So this is negative only. So here actually, so if you simplify it, you are going to get the negative only. Yeah, you are correct, Ravindra. Yeah. So I hope everybody understood. Any questions on this? Any questions, anybody? Okay. So note down one more. If u is equal to x cube y cube z cube divided by x cube y cube z cube divided by x cube plus y cube plus z cube plus log of xy plus yz plus zx xy plus yz plus zx divided by x square plus y square plus z square. Find the value of x dou u by dou x plus y dou u by dou y plus z dou u by dou z. Can you find out this value? This will be the last question. Yeah, that's correct, Anubhav. Anybody else? So you need to divide this into two parts. So we call this as V and this as W, and separately apply Euler's homogeneous equation and then add it together. So Kirandeep, you check it. So it should be 6 times of the first part. So here actually this function we call as V and this function we call as W. Now V is nothing but x cube from the, x power 9 from the top and x cube from the bottom. If you take it out, then this will be y by x whole cube into z by x whole cube divided by 1 plus y by x whole cube plus z by x whole cube. Now this is x power 6 into f of y by x format. So for this V, you can apply x dou v by dou x plus y dou v by dou y plus z dou v by dou z is equal to 6 times of V. So this is the first part. And the second part is, this is, I call this as W. W is equal to log of xy plus yz plus zx divided by x square plus y square plus z square. Now this you can take it, e power w is equal to x power 2 divided by x power 2 into f of y or g of y by x format, y by x comma z by x format. Now this is x power 0 into g of y by x into y by x comma z by x format. Now this is power 0. So n is equal to 0. Then so e power w, if I call this as p, then x dou p by dou x plus y dou p by dou y plus z dou p by dou z is equal to 0. Right? So this is equal to 0. Now this 0, so in terms of p, so dou p by dou x is nothing but e power w x into e power w into dou w by dou x plus y into e power w into dou w by dou y plus z into e power w into dou w by dou z is equal to 0. Now e power w you can take it out and cancel, and what is left over is x dou w by dou x plus y dou w by dou y plus z dou w by dou z is equal to 0. Now these two, if you add it together, then what you are going to get it is, that is x times of dou by dou x of u plus w, v plus w plus y times of dou by dou y v plus w plus z times of dou by dou z v plus w is equal to 6v plus 0. So the original answer, x dou u by dou x plus y dou u by dou y plus z dou u by dou y dou z is equal to 6 times of x cube y cube z cube divided by x cube plus y cube plus z cube. So this is the answer. Got it? Understood? Any questions on this? So this is about the Euler's homogeneous equation, right? So the questions that are going to be asked is, so the questions will not be straightforward like x power n into f of y by x format. So these things you need to convert into that format to apply Euler's homogeneous equation. Got it? So this is about the partial differentiation. And then one of the applications of this partial differential equations is finding out the Jacobian. So these Jacobians, like actually when we have the conversion from one coordinate system to another coordinate system. Suppose we have the coordinate system x comma y. Now if you want to convert this into r comma theta, so you are converting from this to this. In that case, so if you suppose if I have some function f of x comma y dx dy, this is a double integral, let us say. Now this double integral, if you want to convert into double integral again, but with a different coordinate system. In this case, here actually x comma y is there. So it will convert into a different function g with the variables r comma theta. And then in such case, there is a Jacobian that comes into picture, dr d theta. This j value we call as Jacobian. Got it? So while finding out the integrations, after transforming the coordinates, to a different coordinate system, the conversion dx dy will become Jacobian times of dr d theta in polar. So not only in polar coordinate system, every coordinate system, if it is converted from one to other, so it has to be multiplied with the corresponding Jacobian. So this Jacobian has to be calculated with the help of partial differentiation. This is one of the application of Jacobian. And another application of Jacobian is finding out the linear dependence. Between the functions. So these are the two important applications of Jacobian. And then the Jacobian is defined as, suppose if I have the Cartesian coordinate system x comma y as the independent variables, this is Cartesian. And then in polar coordinate system I have r comma theta as the variables. Then which essentially means that x is a function of r comma theta and y is also a function of r comma theta. So here x is nothing but r cos theta and y is nothing but r sin theta. If you notice, both are dependent on r and theta. So two independent variables is used to express one variable in the other coordinate system, but this coordinate system has two variables. Got it? Now in such cases, if dx dy, while doing the integration, if you want to convert this into r d theta, then this Jacobian has to be calculated correspondingly. That Jacobian for this is nothing but, j is nothing but the modulus of dou x by dou r, dou x by dou theta, and dou y by dou r, and dou y by dou theta. So this determinant is called as the Jacobian. Got it? So a Jacobian is primarily used for two purposes. One is to find out the dependence between the functions, and another is to find out the Jacobian which is required to calculate the integral after transforming into the another coordinate system. So whatever may be the coordinate system. So if you notice, when we find out the integral, double integral dx dy, what we usually do is after conversion into coordinate system, r dr d theta we take it. So this r is just because of this Jacobian. We will not straight away do dr d theta from dx dy. We multiply with r and then do dr d theta. So that r is nothing but Jacobian. Clear? Understood? Another application is if there is a direct dependence between the functions. So here actually there is a function which involves x comma y and there is a function which involves r comma theta. Now if these two functions, let us say this is u and this is v, if u and v are directly related without using these variables, then that can be found with the help of the Jacobian. If the Jacobian becomes 0, then we can straight away say that these two are directly dependent on each other. Got it? Okay, so note down these applications, then actually we will see how to calculate this Jacobian. Then first we will take the simple case of conversion from Cartesian to polar. Find the Jacobian for converting Cartesian to polar. That is x equal to r cos theta and y is equal to r sin theta. So Jacobian is nothing but j of x comma y r comma theta. So this is dou x dou r dou x dou theta dou y by dou r dou y by dou theta. Now for this actually we need to be finding the determinant. So here dou x by dou r is nothing but cos theta and dou x by dou theta is nothing but minus r sin theta and dou y by dou r is sin theta and dou y by dou theta is r cos theta. So r cos square theta minus of minus plus r sin square theta. So this is r times of cos square theta plus sin square theta. This is r into 1 is equal to r. This is how you will find the Jacobian. Got it? Now you do on your own, find the Jacobian for converting 3D Cartesian to spherical. Note down this, convert this 3D Cartesian to spherical. Can you find this out? So if you want to know the relation, x is equal to r sin theta cos phi y is equal to r sin theta sin phi, z equal to r cos theta. This is the relation. So you have to find out the Jacobian. So Jacobian is nothing but dou x by dou r, dou x by dou theta, dou x by dou phi. Similarly, dou y by dou r, dou y by dou theta, dou y by dou phi, dou z by dou r, dou y by dou z by dou theta, and dou z by dou phi. And to notice, while taking the Jacobian, you always take modulus in the integral. So modulus of j into dr d theta d phi, and this is as equivalent as that of dx dy dz. These two are equivalent. Can you find this with the above relations? Anybody got the answer? Okay, so anybody else? I hope you will be able to do that. So these are straightforward procedures. You just need to do the derivatives and find the determinant. That's it. And one last problem. So this will come as r square sin theta. You can cross check it. It will be straightforward only. So that's why when we convert from Cartesian to polar, you will multiply r square sin theta for dr d theta d phi. If u is equal to x into square root of 1 minus y square plus y into square root of 1 minus x square comma v is equal to sin inverse x plus sin inverse of y so that uv are functionally related. Show that u comma v are functionally related. And find the relation. Find the relation. So functionally related, we mean the Jacobian has to be 0. So find the relation after finding the Jacobian. So j is nothing but modulus of dou u by dou x and dou u by dou y. Similarly, dou v by dou x and dou v by dou y. Find the determinant of this and then check if it is coming out to be 0. Yeah, great. So 2 people got it. I hope everybody should be able to get. So this is straightforward, finding the partial differentiation and then finding the Jacobian. So these two are functionally dependent. Yeah. So u is equal to sin v is correct. So these two are functionally dependent. Why? Because so the Jacobian is vanishing out, right? So what is the functional relation between these two? So from this here itself you can get to know that. So this is v is equal to sin inverse of x plus sin inverse of y, right? So this can be written as sin inverse of, so sin inverse of x plus sin inverse of y. So this is as if like this is phi and this is theta. then x is equal to sine phi and y is equal to sine theta, right? Then obviously cos theta, cos phi will be 1 minus x square under root, and then cos theta will be 1 minus y square under root. Now sum of these two angles. So to take the sine a plus b, if you apply sine a cos b plus cos a sine b. So sine a is nothing but x into square root of 1 minus y square sine a cos b, because sine phi is x and cos phi is, cos b, right? So cos theta is nothing but square root of 1 minus y square plus y into square root of 1 minus x square under root. So this is sine inverse of x into 1 minus y square under root plus y into 1 minus x square under root will be u. So v is equal to sine inverse of u. So this is the relation, functional relation between these two, or sine v is equal to u. So if you notice, we are directly relating the functions avoiding x and y. Got it? So this functional relation can be found provided if this Jacobian is coming out to be 0. Understood? Any questions on this? Okay. So other than Anubhav and Abhinit, nobody else? Any questions? Okay, great. So this is about the Jacobians, right? So in the next class, I'm going to start with curve tracing, right? So once we are done with the curve tracing, then we can go to multivariables. Yeah. So thank you. Yeah, good night.